You're welcome to today's physics lesson. Our topic today is magnetism. Magnetism. And under this topic, we want to know some historical background. Where does the word magnetism come from? Magnetism comes from the word magnesia. Magnesia simply means a place where the first magnet was discovered, and that first magnet was called lodestone. So lodestone was the first magnet ever discovered. So the first magnet was called lodestone and was discovered from a place which was called what? Magnesia. That's where this word magnetism comes from. It comes from the word magnesia. Now, when you look at this word critically, you realize that there is a word magnet in it. So, I want us straight away to look at the word magnet. What do we mean by a magnet? We have said the lodestone was the first magnet. But what is a magnet? A magnet is a material which attracts magnetic substances. A magnet is a material which attracts magnetic substances. Now, what do we mean by magnetic substances? Magnetic substances are those substances which are attracted. These are substances which are easily attracted. You can use the word strongly attracted or easily attracted to a magnet. Materials which are easily attracted to a magnet. And what are the examples? We have examples: steel, iron, cobalt, and nickel. So those substances, steel, iron, cobalt, and nickel, they are strongly attracted to a magnet, and for that matter we call them magnetic substances. So a magnetic substance is that substance which is strongly attracted to a magnet, and we have the examples here as I have said. So if you bring iron, bring steel, bring cobalt or nickel near a magnet will attract it. That's why we are saying that a magnet is a material which attracts magnetic substances. Now, we have two main categories of magnets. We have two main categories of magnets. And what are these categories of magnets? Number one, we have what we call temporary magnets. And then the second one, we have what we call permanent magnets. Now, what are temporary magnets and what are permanent magnets? Temporary magnets are those magnets. These are magnets. These are magnets which keep their magnetism a short time. See, these are magnets which keep their magnetism for a short time. Now, what about permanent magnets? These are magnets which keep their magnetism for a long time. See? So we have magnets, categories of magnets. We said we have temporary magnets and permanent what? Magnets. Temporary magnets are those magnets that keep their magnetism for a short time, while permanent magnets are those magnets which keep their magnetism for a long time. So the key words here are keep magnetism for a long time, while this one, the keyword is keep magnetism for a short time. You see, just like we have permanent houses and temporary houses. Houses that last for a long time, those ones are temporary, and houses that last for a short time, rather, those ones are temporary houses. Then there are houses which stay for a long time, those are permanent houses. So we also have temporary magnets and permanent magnets, those which keep magnetism for a long time and those which keep magnetism for a short time. Now let us look at examples. What are some of the examples? So we are going to divide them into two. What are the examples for temporary magnets and what are the examples for permanent magnets? See, so we are going to have a small table. So we have temporary magnets and we have permanent magnets. So example number one, for temporary magnets, we have what we call electromagnets. And then the second one, we have induced magnets. We have electromagnets and then we have induced magnets. Those are examples of temporary magnets. So these magnets, they keep magnetism for a very short time. But we have also examples of permanent magnets. And the first one here, we shall call it a bar magnet. Then we have a horseshoe magnet. And then we have another good example is the floating compass. See? So these are examples of permanent magnets. We have the bar magnet, the horseshoe magnet, and the floating compass. So these ones, they keep their magnetism for a very, very long time. So we have known examples of temporary magnets and examples of permanent magnets. Now let's look at uses. So let's have Uses of magnets. Where do you use magnets? And we are going to have again a smaller table here so that we talk about where do we use temporary magnets and where do we use permanent magnets. So we shall have a table here. See? So before we give the uses, I want to let you know that temporary magnets are used by instruments that need magnetism for a very short time. There are those instruments that need magnetism for a very short time, while permanent magnets are used by those instruments which require magnetism for a long time. Now, where do we use temporary magnets? The uses are quite many. We have number one, we have what we call electric bells. Temporary magnets are used in electric bells. Some of us and some of you watching, I know you know what an electric bell is, how it looks like. But in case you have not seen, well, time is going to come when we shall talk about it in details. But for now, an electric bell normally is used in some schools. Electric bells are used in some schools. So when it is time of changing lessons or it is break time, the timekeeper simply goes there where the bell is and then switches on. And so long as there is a current, there is electricity in the school, the bell will ring. But when there is no electricity, it will not ring. So that electric bell uses a magnet, but the magnet is temporary magnet. Another use of a temporary magnet is we use them in transformer cores. Transformer cores. Yes, as long as you have electricity in your home, then there should be a transformer which is near, that is supplying you with that current, that is managing the current around your area. Now the core of a transformer, inside the core of the transformer cores need temporary magnets. They need magnetism for a short time. We shall talk about transformers later. Number three, temporary magnets are also used in telephone receivers. For those who have the phones, when somebody rings, there is that part which you put in the ear. That one is called the telephone receiver, or it is called the telephone earpiece. Inside the telephone receiver, there is a magnet, and that magnet is what? A temporary magnet. It needs magnetism for a very short time, for only that time when the person is talking to you. After that, the magnetism is not what? Required. We also have other uses, and in this case, there is another use in what we call magnetic relays. Magnetic relays. If you don't want to call it a magnetic relay, you call it solenoid switches. Solenoid what? Switches. This is an E. Switches. So a magnetic relay also needs magnetism for a very short time. So for that reason, it needs a temporary magnet. We can also use them in recording tapes. recording tapes of tape recorders. Now, all these are uses of temporary magnets. Now, we also have uses of permanent magnets. So the first one is we can use a permanent magnet to remove iron objects in the ear or from the ear. See, sometimes we have children, and you know children, they keep learning. Some learn by putting very many things in their ears, in their mouths, like that. So in case a child gets a small piece of iron metal and puts in the ear and it gets stuck in the ear, how do you remove it? There are two ways. You can go to the hospital, yes, and the doctor will tell you we need surgery. That means there is going to be a lot of pain and many other things. Surgery, that is one way. The second one, they can tell you we are going to use a magnet. So if you have a strong magnet at home, you can try to put it. A strong magnet in this case could be a bar magnet, could be a horseshoe magnet. In fact, it should be a permanent magnet. It should be a magnet which has magnetism. It keeps the magnetism for a long time so that anytime you want it, it is there. So if you get a permanent magnet like a bar magnet and you put near the outer ear of that kid, because the magnet is very strong, it has strong magnetism, it will attract the iron which is stuck in the ear. But it may not only be iron. It may be iron, it can be steel, it can be nickel, it can be what? I said examples of these things which can be attracted by a magnet are iron, I remember saying that, steel, nickel, and cobalt. If one of those things is stuck in the ear, because these things can be attracted by a magnet, you simply bring the permanent magnet near the outer ear, and the permanent magnet will attract the iron object and will remove it. So that is a very good use of a permanent magnet in daily life. Apart from that, we can also use permanent magnets in instruments called ammeters. Ammeters. What are ammeters? Ammeters are those instruments used to measure current, electric current. So inside that instrument, inside an ammeter, there is a permanent magnet. So an ammeter needs magnetism for a long time. Therefore, there is a permanent magnet. We also use permanent magnets to make computer disks. Computer disks. Now we are now in a computer world. So those computer disks have magnets, and the magnets must be permanent because a computer disk needs magnetism for a long time. We also have magnets having very important use. We use them to locate direction. That is what? Compass direction. For example, the fishermen, when you are inside the water, you may not know where is the north, which side is the south, which side is what? West. So if you have your floating compass, which is a permanent magnet, you can use it to locate the compass direction, which side is the north and which one is south. We also use magnets in machines called DC motors. DC motors. DC is not related to Washington DC in America, but DC here means direct current. So DC means direct current. There is also what we call AC. AC means alternating current. So you need to know these abbreviations. Now we are talking about DC, but time is going to come we shall also meet the word AC. AC means alternating current. Both of them are currents. One is direct, one is alternating. These are their abbreviations. So when I say a DC motor, I mean a motor which uses direct current. Most of these motors are used in grinding machines, where we go and grind to mill our maize so that we can have posho flour and so on. There is a motor there. So those motors, we call them DC motors, direct current motors, and they use permanent magnets. We also have another instrument called a moving coil, galvanometer, a galvanometer. Very good. Now, this one we shall also look at it later. So we use them, you can say, in moving coil galvanometer. So briefly, this is how now our table looks like. Uses of magnets, temporary magnets and permanent magnets. So if somebody says list 4 uses or list uses of magnets, that person has given you the freedom. You can list all of them, uses of both temporary magnets and permanent, because both of them are magnets. But if the examiner says list uses of temporary magnets, then the right answers are on this table. And if the examiner says list uses of permanent magnets, then the right answers are on this side. Now, sometimes these examiners are very tricky. They may not use the word uses, but they can decide to use the word practical application. Practical applications. Practical applications, meaning where do you use in daily life? Where do you use this? So when we say state one practical application of a temporary magnet, where do you use? That question requires, where do you use a temporary magnet in daily life? And the answers remain the same. And the same with the permanent magnets. Now, I want us to move to another level. And this time, we are going to talk about properties of a magnet. Properties of a magnet. Yes, you can know a magnet by using its properties. Now, what are the properties of a magnet? Property number 1, a magnet has 2 poles. See, a magnet has 2 poles. We can name those poles. We have what we call the North Pole and South Pole. You can put S to mean south, and then you just put a dash, and then you put the word pole, or you write south in full. It is accepted. Even this north pole, I can just write N, I put a dash, and I put a pole. It is allowed. So a magnet has two poles. So assuming this is a magnet, and by the way, it is very easy to draw a magnet. You just draw a rectangle, and then one side you put N close to the end, and then one side you put S also close to the end. Don't write this N in the middle here or the S. It must be at the near the end. In other words, we are saying the poles of a magnet are always at the ends, not in the middle. So N here means North Pole, and S means South Pole. Yes. So a magnet has two poles. What are the names of those poles? The North Pole and the South Pole. Now, I am not saying whenever you're drawing a magnet, the north must be here and the south must be here. No. You can even draw it like this, and your north is this way, and your south is this way. It still remains what? A magnet, as long as there is a north and south poles. So that is the first property of a magnet. Now, the second property of a magnet is that a magnet attracts magnetic substances. And we have already given examples of those magnetic substances. We have iron, we have steel, we have nickel, and we have cobalt. You see, a magnet attracts magnetic substances. And examples of magnetic substances are iron, steel, nickel, and cobalt. Very good. The other property of a magnet, the third one, is like poles. Like poles of a magnet repel and unlike poles attract. Yes, like poles of a magnet repel and unlike poles attract. What do you mean by like poles? The word like means similar. Similar means if you bring the north and the north near each other, or you bring the south near the south, then you expect them to do what? You expect them to repel. See? But if you bring unlike poles, unlike means they are not the same. North, south, you bring it near north. The south of this magnet near the north of the other one. They will end up what? Attracting. So that one is point number 3. Now, point number 4 about a magnet, that a magnet freely suspended. Freely suspended swings to and fro in a horizontal plane and comes to rest in north to south direction. Yes. So when you suspend a magnet, if this is a magnet, and then you tie a thread, and then you hang it, you suspend it using a what? A string. If that is your magnet, what that magnet will do will swing, and you'll be swinging horizontally, not vertically. Then time is going to come when it will stop swinging. When it stops swinging, we use the word what? Comes to rest. When it comes to rest, you realize that one pole of the magnet will be facing north, and another pole will be facing what? South. Now, research has shown that the pole which faces to the north, if this is our compass direction, north and south, east and what? West. So when this thing stops swinging, one side will be facing north and one side will be facing what? South. Now, the pole which will be facing north is also the north pole, and the pole which will be facing south will also be called the south pole. You can call it north pole, or you call it the north seeking pole. Then for the south pole, you can also call it the south pole, or you call it the south seeking pole. Why do you call it the north seeking pole? Because it is the pole which is facing the north. And why do you call it the south seeking pole? Because it's the pole which is facing the south. Thank you. Yes, let's continue with our lesson. Whenever you are dealing with the magnetism as a topic, there are some terminologies, terms, common terms that you are going to meet. And so let's look at some common terms in magnetism as a topic. Let's look at some of these terms.